Imagine a world where death is nothing more than an illusion, a boundary we believe in but one that might not actually exist. What if aging wasn't an unstoppable force but simply an accumulation of molecular errors, a problem that could one day be solved? What if your consciousness never truly ceased to exist but instead continued in a different version of reality? This is where quantum mechanics, cutting-edge technology, and theoretical physics collide in one of the most mind-bending ideas of all time: quantum immortality. Renowned physicist Michio Kaku has often explored the radical idea that death as we perceive it may not be absolute. According to him, both biological and quantum immortality could be within reach. Scientists are already making breakthroughs in reversing the aging process, repairing DNA, and exploring the potential of quantum mechanics in reshaping our understanding of life itself. But could this go even further? Could our consciousness itself be immune to death, shifting between different quantum realities forever? In this deep dive, we'll explore the science, the theories, and the astonishing implications of quantum immortality. Prepare to question everything you thought you knew about life, death, and reality itself. Aging, a problem that could be solved. Aging, in its simplest form, is the accumulation of errors, tiny molecular mistakes that build up over time. Each time a cell divides, minor errors occur in DNA replication, proteins misfold, mitochondria degrade, and eventually, these errors lead to the breakdown of tissues, organ failure, and ultimately death. But what if we could correct these errors at the molecular level? Some creatures already defy aging. The hydra, a tiny freshwater organism, is biologically immortal. Its cells continuously regenerate without accumulating damage. Certain jellyfish can revert back to their juvenile state, essentially restarting their life cycle indefinitely. If nature has already cracked the code for immortality, could humans do the same? Tech entrepreneurs and biologists are pouring billions into anti-aging research, seeking ways to halt or even reverse cellular decay. Breakthroughs in genetic engineering, stem cell therapy, and advanced pharmaceuticals could hold the key. But this is only half the story. Quantum immortality, is death an illusion? While biological immortality focuses on preventing death from aging, quantum immortality suggests that death itself may be an illusion. Quantum mechanics is a realm of uncertainty, probability, and mind-bending paradoxes. One of the most controversial interpretations is the many-worlds interpretation, MWI. According to this theory, every quantum event causes the universe to split into multiple realities, each playing out a different possible outcome. What does this mean for consciousness? Suppose you find yourself in a life-threatening situation, a plane crash, a terminal illness, an accident. In most realities you perish, but in some, you miraculously survive. According to quantum immortality, from your own subjective experience, you would only ever exist in the realities where you continue to live. In this way, you never actually experience death. This leads to a fascinating but eerie thought. If quantum immortality is real, then from your own perspective, you are functionally eternal. No matter how many close calls you have, there will always be a version of reality where you persist. The consciousness conundrum. But if this were true, why don't we remember dying before? Does the human mind operate on quantum principles? Some researchers believe it does. The Penrose-Hameroff orchestrated objective reduction, orchestra theory suggests that consciousness arises from quantum processes within neurons. If true, this could explain how consciousness might persist across multiple realities. Quantum coherence, a property observed in biological systems like photosynthesis, shows that living organisms already exploit quantum mechanics in ways we don't fully understand. Could our consciousness do the same? Could it function like a quantum wave, existing in multiple states until measured by observation? However, mainstream science remains skeptical. The brain is a warm, wet environment, conditions that typically destroy fragile quantum states. If quantum mechanics plays a role in consciousness, we have yet to find definitive proof. Can quantum immortality be tested? The quantum suicide experiment is a disturbing thought experiment designed to explore the implications of the many-worlds interpretation. Imagine a scientist sets up a machine linked to a quantum particle in superposition. Every time the particle is measured, it randomly lands in one of two states. If it lands in state A, the scientist survives. If it lands in state B, the machine instantly kills them. From an outsider's perspective, the scientist eventually perishes. But from the scientist's own perspective, they will only ever experience the outcomes where they continue to survive. Every time the universe splits, they find themselves in the reality where they are still alive. In this way, they are effectively immortal, at least from their own point of view. Does this prove quantum immortality? Not necessarily. The problem is that survival bias makes it impossible to verify. The scientist may believe they are immortal, but in every other branch of reality they are dead. Major challenges to quantum immortality. Even if the many worlds interpretation is correct, quantum immortality faces several major problems. No memory of past deaths. If we truly transition between realities where we survive, why don't we remember previous deaths? Some speculate that memories may be locked to each universe, meaning we wouldn't retain them across different versions of reality. Probability issues. Over time, the odds of surviving every possible fatal event become astronomically small. If quantum immortality were real, why don't we see clear evidence of people surviving against impossible odds all the time? The observer problem. Many worlds suggest that all possible outcomes exist, but it doesn't necessarily mean our consciousness experiences all of them. It's unclear whether consciousness itself follows the same quantum rules as subatomic particles. The role of quantum computing. Quantum computers could revolutionize our understanding of both biological and quantum immortality. Unlike classical computers, which process information linearly, quantum computers can analyze vast amounts of data simultaneously, simulating complex biological processes at the molecular level. By modeling DNA repair mechanisms, protein synthesis, and cellular aging, quantum computers could help scientists unlock the secrets to halting or reversing aging. If biological immortality is possible, quantum computers will likely be the tool that makes it a reality. A new perspective on existence. If quantum immortality were true, it would fundamentally change our understanding of life and death. Instead of a single linear existence, life would be an infinite web of branching realities, each inhabited by a different version of you. Death, from this perspective, would be relative. While others might see you die, your consciousness would continue uninterrupted in another reality. This raises profound questions about identity and selfhood. Are we a singular self, or are we an infinite number of versions of ourselves, each navigating their own path through different realities? Final thoughts. Quantum immortality forces us to rethink some of the most fundamental questions about existence. Is death truly the end, or does something else happen beyond our perception? Does consciousness obey quantum rules, or is it purely a biological phenomenon? As we continue to explore these questions, one thing is clear: the mysteries of quantum mechanics and consciousness are far from solved. And perhaps, in the words of Michio Kaku, the universe is even stranger than we imagined. If you've enjoyed this deep dive into the mysteries of quantum physics, be sure to subscribe for more explorations into the biggest questions of existence.